Hi, hello, welcome to Dr. Zahir Math. In this video, we are taking things a step further. We will learn how to diagonalize a 3 by 3 matrix. Okay? If you understood the 2 by 2 diagonalization, this is a perfect follow-up. Diagonalization is a super useful in engineering applications like, which I told you in 2 by 2 matrix, stability analysis, model analysis, and simplifying matrix exponentials in systems of differential equations. This might look a bit bigger, but the process is just as logical. What we did for 2 by 2, the same we are going to extend it for 3 by 3. And I'm going to make sure it's easy to follow. Let's start diagonalization A matrix, which is a 3 by 3 matrix. What is the step I told you? Step number 1, you're going to find eigenvalues. Okay, right. And step number 2, you're going to find out eigenvectors. Step number 2 is what? To find eigenvectors, right. And step number 3 is what? You're going to create a model matrix. Okay, so we are going to create a model matrix, right? Model matrix, right, which is P, right, with the help of what? Eigenvectors. With the help of eigenvectors, right. And what is the next step I told you? Step number 4. Step number 4, you are going to find out P inverse directly from the calculator. Directly from the calculator, keep in your mind, right. And step number 5 is we are going to find P inverse AP, which is equal to a diagonalized matrix. Keep in your mind, the diagonal elements will be your lambda 1, lambda 2 and lambda 3. Your answer should get it. Keep in your mind. So these are the steps we are going to follow. Let's start the solution, right? Okay. Yes. So we are going to start first one, right? Yes. What is the characteristic equation, right? It's a 3 by 3 matrix, right? So lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 is equal to 0, right? So what's your beta 1? Beta 1 is equal to sum of leading diagonal elements. Sum of leading diagonal elements. So what do you mean by the leading diagonal here? 8 plus 7 plus 3, right? So which is equal to 8 plus 7 plus 3, which is equal to 7 plus 3 is 10, 18. So beta 1 is equal to 18. Sometimes they call this as a trace also, they will call. Trace of A. Instead of saying the leading diagonal, they will tell you trace of the matrix A, right? Let's go to beta 2. Beta 2 is equal to what? Sum of minors of leading diagonal elements. Sum of minors of leading diagonal elements. Okay, right. Let me take the matrix over here so that no need to move here and there. 8 minus 6, 2, minus 6, 7, minus 4, and 2, minus 4, and 3, right. So let me take the minus. There are 3 minus, you're going to take it, right. So the first minor for this one, you're not going to take this row, right, and you're not going to take this column. So it will be 7, okay, minus 4, and 3, right. Right. Next, we are going to take the leading diagonal is this one. So this row you're going to not going to take, and this column you're not going to take. So it will be 8, 2 and 2, 3, right? Yes. For this diagonal matrix, diagonal element, and this we are not going to take, and this column we are not going to take. So it is 8 minus 6, 7, right? Yes. Okay. Now we are going to evaluate this determinant, which is 7 times 3 is 21 minus 16 plus 8 times 3 is 24 minus 4 plus 8 sevens are how much? 8 sevens are 56. Okay, right. And then minus 36. 8 times 7, which is equal to 56, minus into minus plus. So it's going to become minus 36. So let me simplify in the calculator. 21 minus 16 and then plus 24 minus 4 and then plus 56 minus 36. It's equal to 45. So beta 2 is equal to 45, right? Yes. Let me go for calculating beta 3, right? Beta 3 is equal to determinant of A. That means you are going to put in the calculator, right? So we have the matrix. So I told you already these steps, very clear. Mode, and then you're going to press 6. Then you're going to press 1 and again it's 1. So mode 6, 1, again 1 because it's a 3 by 3 matrix. So you give the entries, okay, 8 and then minus 6 and then 2 and then minus 6 then 7 and then minus 4 then 2 minus 4 and then 3. Press AC. After that you are going to use shift 4, then you are going to find the determinant, right? So it is number 7, and then again shift 4, and your data is in number 3. So you press number 3, then close it with the brackets. So it will be det of mat A. So det of mat A is mate A, right? Which is equal to det of mat A is 0. So you are getting beta 3 is equal to 0. If beta 3 is 0, one of the eigenvalue will be 0. Keep in your mind. This is also one shortcut. Right, so finally let us put all these values in the equation. Lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3. So lambda cube minus, what is your beta 1? I think 18 we got it. And beta 2 we got it as what? 45 lambda minus beta 3 equal to 0. Now you have to take your calculator, which is mode 5. Okay, mode 5 equation. After that it's 4. Mode 5, 4. Right, give this input. 1 equal minus 18 equal 45 equal and then 0 equal. Also 0 also you have to give. So you get lambda is equal to 15. Okay, and 3 and then you will get 0. Let me write in the order 0, 3, 15. So not necessary, but still I feel like this. Lambda 0, 3, 15. Okay, right. So this is your eigenvalue, right? This is what? This is your eigenvalue. Next we are going for eigenvector, right? Eigenvector, which is step number 2, right? Step number 1 is what? Finding eigenvalue, right? And this is step number 1, right? Now we are going for step number 2, finding eigenvalue. Sorry, eigenvector, right? What is the formula? Matrix A minus lambda I times x is equal to 0, right? So I told you that it takes only in the diagonal part it will take, that is 8 minus lambda minus 6 and then 2 minus 6 7 minus lambda then minus 4 and then 2 then minus 4 3 minus lambda times you are going to take x1 x2 x3, right? This is equal to 0 0 0. How I got this? Let me write the matrix here once again, which is 8 minus 6 2, then minus 6 7 minus 4 and then 2 minus 4 3. Okay, look at the matrix everybody. The changes only takes place in the diagonal. Look here, 8 minus lambda, 7 minus lambda, 3 minus lambda. Remaining elements are same, minus 6 2 minus 6 and then minus 4 2 minus 4. So this one I'm going to call it as equation number 1. So this one I'm going to call it as equation number 1. Okay, right. Now let's take case 1, right? Lambda is equal to 0. If I take lambda is equal to 0, 8 and then minus 6 2 and then minus 6 7 minus 4 and then 2 minus 4 and then 3. This operating on x1 x2 x3, right, which is equal to 0 0 0. Try to write two equations. Most probably you will get non-zero vector. Right, 8x1 minus 6x2 plus 2x3, right? This is x3, right? So first row, first column, and second row, first column, right? Minus 6x1 plus 7x2 minus 4x3 is equal to 0, right? So we are going to take what? Method of cross multiplication, right? So we are going to get start from the middle and end with the middle. So what we are going to get it, minus 6 and then 2 and then 8 minus 6, then 7 minus 4, 6 minus 6 and then 7, right? So what we are going to do, x1, right? What we are going to do, x1 divided by and x2 divided by and x3 divided by 6 into 4, how much? Which is 24, right? Minus 7 into 2 is what? 14, right? 2 into 6 is minus 12 and minus 4 into 8 fours are 32, which is going to be plus 8 sevens are 56, okay, and then it's going to become minus 6 36, so which is going to become minus 36. So therefore x1 divided by 24 minus 14, which is going to become 10, and x2 is equal to, right, divided by 32 minus 12. So 32 minus 12, it is going to become what? Which is going to become 20, right? 20 plus 12 is 32, right? So x3 divided by 56 minus 30 is also going to become what? 20, right? 32 minus 12, shift 9 3, okay, 32 minus 12, right? Sometimes I have to make sure. So what happens now? Can I cancel with the common table? Yes, of course you can cancel with the 10 table. 1 and this is 2 and this is 2. So therefore your x divided by 1 and y divided by 2 and z divided by 2. Not x. I'm using x1, y1, right? Yes, sorry. x1, x2. So x1 divided by 1 and x2 divided by 2 and x3 divided by what? 3. Some teachers, sorry, 2, again I'm making mistakes, right, divided by 2. Some teachers, instead of x1, x2, x3, they will use x, y, z also. Nothing wrong in that. Both are going to be same. So we are going to write the first eigenvector as what? 1 2 2, right? This is your first eigenvector, right? Let's go for case 2. Case 2, we are going to put, right, we are going to put what? Lambda is equal to 3 in equation 1. Okay, so I'm going to put lambda is equal to 3 in equation 1 and then operating on x1, x2, x3, right? Which is equal to 0, 0, 0. I have the matrix in my hand. I'm going to write all the other elements. Then the diagonal elements, I'll show you how it is changing. Minus 6, no change. 2, no change. Minus 6, no change. Minus 4, no change. And 2 and minus 4, no change. Okay, yeah. So let me go and put lambda is equal to 3 in equation number 1. So if I put here 8 minus 3 is first one. 8 minus 3 is 5. And 7 minus 3 is going to become 4. And 3 minus 3 is going to become 0. So in the diagonal elements, 5, 4, 0. Okay, yeah. So it will be 5, it will be 4, it will be 0. Right. Let me write two equations, right? Minus 5x1 plus 5x1 minus 6x2 plus 2x3 is equal to 0. And minus 6x1 and then plus 4x2 minus 4x3 is equal to 0. Let me start the method of cross multiplication. So minus 6, 2, 5, minus 6. Start from the middle, come to the middle. So it's 4, minus 6 and then 4. So therefore x1 divided by 6 into 4 is how much? 24, right? And then minus 8. Because it's minus minus plus and this is going to become minus. I told you already previous videos. You can check it out. x2 divided by 2 times 6 is minus 12. And then it's going to become 5 fours are 20, which is going to become plus 20. So x3 divided by 5 fours are 20 and 6 6 are 36, which is going to become minus 36. So x1 divided by 24 minus 8 is 16 and x2 divided by 12 minus 20, sorry, 20 minus 12 is going to become 8 and x3 divided by 20 minus 36, which is going to become minus 16. Is there a common table, teacher? Yes, it's there. So which table? 8 table. So this will be 2 and this will be 1 and this will be minus 2. So finally your will be x1 divided by 2. Let me use another color. Already yellow color is coming. So x1 divided by 2, right? And x2 divided by 1 and x3 divided by minus 2. So finally we are going to get the next eigenvector as 2, 1, minus 2, right? So 2, 1, minus 2 is the next eigenvector, right? So the eigenvector, this is corresponding to lambda is equal to what? 3, right? This is the next eigenvector. Let me go for case 3, right? So case 3, right? We are going to put lambda is equal to 15, right? In equation 1, right? Lambda is equal to 15 in equation 1. So again I'm telling, I have the matrix in my hand, so I'm going to write the, without the diagonal elements, I will write all these things, minus 6 here and 2 here, minus 6 here, minus 4 here, no change, and 2 and minus 4 here. So these elements I'm going to pick it after putting lambda is equal to 15 in the equation number 1. So you'll get x1, x2, x3, right, which is equal to 0, 0, 0, right. So let me put lambda is equal to 15, I'll come back to you, right. Lambda is equal to 15 in equation 1, right. If I put lambda is equal to 15 here, 8 minus 15, 8 minus 15 is minus 7. 7 minus 15, which is going to become minus 8. 3 minus 15, it's going to become minus 12. So minus 7, minus 8, minus 12. Minus 7, minus 8, minus 12. Minus 7, okay, minus 8 and minus 12, right. So let me write two set of equations now. Minus 7x1, okay, minus 7x1, and then minus 6x2 plus 2x3 is equal to 0. Minus 6x1 minus 8x2 minus 4x3 is equal to 0. Okay, again I'll repeat, minus 7x1 minus 6x2 plus 2x3 equal to 0, minus 6x1 minus 8x2 minus 4x3 is equal to 0. Let me start the method of cross multiplication. So let me start from the middle, okay, right, which is minus 6, 2, minus 7, minus 6, end in the middle, minus 8, minus 4, minus 6, minus 8. So x1 divided by equals x2 divided by equals x3 divided by equals 6 into 4 is 24 and 8 into 2 is 16, so which is going to become plus, there is a minus. 2 into minus 6 is minus 12 and 4 into 7 is 28, so which is going to become minus 28. Because here 2 into 6 minus 12, this becomes already plus, the rule is minus. 7 into 8 is 56, okay, and again minus 6 into 6 is 36, so which is going to become 36, because already it's going to become plus, so it is going to become minus. So in this way your x1 divided by 24 plus 16 is how much, 40, and x2 divided by 28 minus 12, which is also going to become 30 or 40, okay, which is minus 40, and x3 divided by, okay, which is equal to 56 minus 36, which is going to become 20, right. So is there a common table, teacher? Yes, you have a 10 table is there, you can cancel it, or you can have it the 20 table, whatever it is you can say. So if I cancel this one, I'll get 2, I will get here, if I cancel I'll get minus 2, here I'll get 1. It's a common table, 20 you can say, right. So finally I'll get x1 divided by 2 and x2 divided by minus 2, am I right? Yes, and x3 divided by 1, okay. So what will be an eigenvector x3? x3 will be 2 minus 2, 1. So this is my third eigenvector. So this is my third eigenvector and this is my second eigenvector and this is my first eigenvector. This is corresponding to lambda is equal to 0 and this is corresponding to lambda is equal to 3 and this is corresponding to lambda is equal to what? 15, right? Corresponding to lambda is equal to 15. So step number 2 is finished. Let me go for step number 3. So what is step number 3? Step number 3, we are going to create a model matrix, right? So which is P, create matrix P. So with the help of what? Eigenvectors. So you take x1, x2, x3. x3 I have now 2 minus 2, 1. So what is your x2? Your x2 is 2, 1 minus 2. So I will get 2, 1 minus 2. 2, 1 minus 2. Okay, next is x1. I'm going to take it. I think it's 1, 2, 2 if I remember. Oh, it says 1, 2. Yes, 1, 2, 2. x1 is 1, 2, 2. So which is 1, 2, 2, right? We created the matrix P, right? After that, what we are going to create? We are going to create step number 4, which is P inverse. We are going to create P inverse directly from the calculator, this one. Directly from the calculator, no need. If there is a question, separate question for inverse, then you have to use formulas, methods. But here in between it is coming P inverse. Again, restart your calculator, right? Shift 9, 3, okay. So now it's mode and then 6 and then number 1 and number 1. So we are going with mode, right? 6 1 1. So 3 by 3 matrix, which is 1 2 2 and then 2, then 1, then minus 2, then 2 minus 2, then 1. Press AC. Okay, after that what you're going to do, shift 4. After that you're going to use shift 4, right? And you have a mat A which is 3, so number 3. So please use the bracket. The screen will be like this. Mat A, use the brackets. So just use the brackets on both sides. Okay, right? So just use the brackets on both sides and then move the cursors to the till end. Okay, right? And then press the button X inverse. Press the button X inverse and press equal. If you press equal, you will get P inverse is 1 over 9. Okay, and press the next one, 2 over 9, and then press next one, which is 2 over 9, and then come to the next row, go to the left, it is 2 over 9. Okay, the next is 1 over 9, the next is minus 2 over 9, and come down to the left, which is 2 over 9. Okay, the next is minus 2 over 9, and the next is 1 over 9. Okay, right? Now this is your inverse. Let me write this one little bit bigger, and also this is little bit bigger. So this is your P inverse, right? We calculated. Now we are going for step number 5, right? What is your step number 5? Step number 5 is P inverse AP. You need to get a diagonal matrix. P inverse just now we calculated. Let me write from here. So which is 1 by 9. Okay, I'll use another color. So which is 1 by 9, 2 by 9, 2 by 9, 2 by 9, and 1 by 9, minus 2 by 9, 2 by 9, minus 2 by 9, 1 by 9. This is your P inverse. Then your A matrix is your question, right? So the question which is given, I have the question in my hand, which is 8 minus 6, 2, and minus 6, 7, minus 4, and 2, minus 4, and 3. And the P matrix we just created just now with the help of eigenvectors 1, 2, 2, 1, 2, 2, right? And 2, 1, minus 2. So 2, 1, minus 2, right? The next is 2 minus 2, right? And then 1, right? So what we are going to do in the calculator, we are going to give this input as mat A, and this input as we are going to put mat B, and this input we are going to give it as what? Mat C. And then finally we are going to multiply. Let's start now. Okay, restart again. Shift 9 3 equals. Okay, right. Now first I'm going to give mat A. Yes, now mode and then 6 and then number 1. So 3 by 3 matrix, so number 1 mat A. So which is 1 divided by 9 equal, then 2 divided by 9 equal, 2 divided by 9 equal. Okay, am I right? Okay, this is P inverse, right? Then after that, next 2 divided by 9, use the divide symbol. Okay, press equal, then press equal, then 1 divided by 9, 1 divided by 9. Okay, then minus 2 divided by 9, press equal, 2 divided by 9, press equal, minus 2 divided by 9, sorry, minus 2 divided by 9. Okay, then the next is 1 divided by 9. Okay, so now everything is gone inside for matrix P inverse, which is mat A. Press AC. Then after that you just go for again mode and then matrix 6, and then now you give the input as number 2. When you give the number input 2, again press 1, that is 3 by 3 matrix. So give 8 minus 6 and then 2, then minus 6, then 7, then minus 4, and then 2, then minus 4, then 3. Okay, then press AC. Then again mode, press matrix which is 6, and then now press 3 which is mat C. So press 1 again, right? So this is 1, then 2, then 2, then 2, then 1, then minus 2, then 2, minus 2, then 1, press AC. Yes, all the data is inside mat A, mat B, mat C. Now what we are going to do? We are going to use shift 4 for everything. right? Now shift 4, right? Mat A, the screen will come as mat A, right? Again use the multiply symbol, then again shift 4, right? Now it is in mat B, so press 4, so which is mat B. Again press the symbol multiply, right? So when you press multiply, what happens? Again shift 4, use it. Now your data is in 5, so math C, you're going to get math C. Now you press equal sign, okay? When you press equal sign, wow, fantastic. I'm getting 0, 3, 15, and all the remaining elements are zeros. Exactly, I'm getting in the calculator. Okay, so I told you this is your lambda 1, this is your lambda 2, this is your lambda 3. Suppose you change your positions of the lambda. Suppose you case 1 you discuss 15, case 2 you discuss for example 3, case 3 you discuss 0. So it will come in the same order. What is your case 1? That is your first one. What is your case 2? That is your second one. And what is your case 3? That is your third one. So in this way, this is going to become what? Your diagonalized matrix. Okay, right. It is your diagonalized matrix, right? So we are going to get the diagonalized matrix. Yes. Now this finishes your 3 by 3 matrix diagonalization. Okay. So great job sticking with me. Now you have seen how to diagonalize a 3 by 3 matrix and how it connects to real world engineering problems, right? Practice few more problems and you will start to feel confident with this topic, because practice makes the man perfect. So you should keep practicing. If this really helped you, don't forget to like the video and comment the video. Please subscribe for more lessons like this. See you in the next video, right? Take care. Bye bye.